This is section 3.6, Polynomial and Rational Inequalities. We'll begin solving polynomial inequalities. Now, in order to solve a nonlinear inequality where f of x is less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0, any of these cases of this inequality, we will first rearrange the terms of the inequality so that one side is set to 0. Then we will find the real solutions of the related equation f of x equals 0. So we'll set f of x equal to 0. We'll find those real solutions and also the solutions that make f of x undefined. So we'll be looking for both of those. And these become the boundary points for the solution set to the inequality. Then we will determine the sign of f of x on the intervals defined by the boundary points. So here we will make what we call a sign chart, and I'll show you how to do that. And if the function is positive, those y values are positive, then the values of x on the interval are solutions to f of x is greater than 0. And that's the same if f of x is negative. Then the values of x on the interval are solutions to f of x is less than 0. Then we will determine whether the boundary points are included or not included in that solution set. Let's give one a try. We're going to begin with number 1 and we will solve for x. Now, the first thing we need to do, as you can see in this first, is to set one side equal to 0. So we have just a little bit of work to do. So let's go ahead and distribute that x. So we have x squared minus 2x is less than or equal to 15. Now we'll go ahead and subtract 15 from both sides. And now we can set up f of x is equal to 0. So now we'll go ahead and let me just move this over here. And now we're going to solve f of x equals 0. So we have x squared minus 2x minus 15 is equal to 0. And factoring that, we have x minus 5 multiplied by x plus 2 is equal to 0. And the solutions to f of x equal to 0 are x is equal to 5 and negative, and I think this was supposed to be a 3. 5 and a negative 3. Okay, so now we're going to create this sign chart. So let me show you how to do that. And we will place any values that made f of x equal 0 and any x values that were undefined. And we didn't have any undefined, so we will just place negative 3 and a positive 5 on our sign chart. Test values, and let me just write test here. And we're going to plug in any value you want anywhere, any x values that are less than negative 3. I don't know, let's try a negative 4. And then we'll try, of course, we always like 0, that's in this interval. And then we'll try x equal to 6, but you could have chosen any value after 5, okay? Now, plugging those values into x minus 5 and x plus 3, what will we have? We will have a negative value if we plug negative 4 into x minus 5. And we will also have a negative value if we plug negative 4 into x plus 3. Okay, let's try that for 0. Here we would have a negative, but here we would have a positive because 0 plus 3 is a positive number. It's 3. And now plugging in 6, we have a positive and a positive. Now, if we multiply a negative multiplied by a negative, of course, we're going to have a positive. And if we plug And if we multiply a negative multiplied by a positive, that's a negative, and a positive multiplied by a positive, we have a positive. Well, what we are looking for in this problem is less than or equal. So here we have negative. This would be positive, and this would be positive. So what we have here, let me see if I can move some of this up just a little bit so it looks a little bit better. Okay, and this is what we're looking for right here, this interval. Now, we want less than or equal, so we will include these endpoints. So we will have -3 to 5, and that is actually going to be our solution. See if I can move that over here and then grab this. Okay? Okay, now let's take a look at this graph. As you can see, here is -3 and here is a +5. And if this is f of x, this is the area right here where f of x is less than or equal to 0. So it's on this interval that we have y values that are less than or equal to 0, which solves this equation right here. Okay, let's go ahead and try number 2. We are starting with x -2 squared multiplied by x plus 3. And as you can see, this is already factored for us, and we already have 0 on the right-hand side. So our solutions are x equal to 2 and x equal to -3. Now this time we're looking where x is greater than 0. Okay, let's see if we can look over at the graph and come and give our solution before we do the algebra. So the graphical solution, what do you notice? We are greater than 0 from -3, but we don't want greater than or equal, so we need to put open circles here. So we have -3 going all the way to 2, and then we will begin at 2 and go all the way to infinity. So let's see now if we can find the algebraic solution using our sign chart. So again, we will make this really nice sign chart. And we will put our solutions on here, -3 and 2, and we will have these open at -3 and 2. And let's go ahead and test. And we can test -4. Of course, we will choose 0 again, and then 3. Okay, and plugging these in, we have our two factors, which is x -2 all squared and x plus 3. And what do you notice? X -2 all squared is always going to be positive, no matter what number you plug in. And then plugging in a -4 and a 0 and a 3 is what we would get. Now, multiplying these two together, we would have a negative. A positive is a positive is a positive, and a positive multiplied by a positive is a positive. Now, we are looking for positive, so that's what we want, but we only want greater than 0, so we do not want to include those boundaries. So now, as you can see, we will have -3 to 2 unioned with 2 to infinity. Okay, now let's take a look at this next inequality. 4x squared minus 20x plus 25 is less than or equal to 0. So what we have here is we can take a look at solving f of x is equal to 0 first. And we have 4x squared minus 20x plus 25 is equal to 0. And obviously you can see that this is a perfect square. 2x minus 5 all squared. So x is equal to 5/2. Well, we know that if we have 2x minus 5 all squared is less than or equal to 0, looking at this, you know that this can never be less than 0 when we square. It can only be equal to 0. So our solution is just 5/2. We just have 1 point for our solution. Let's look at number 4. Here we have less than 0, okay? And it's the same quadratic. So we will have 2x minus 5 all squared is less than 0. Well, this is never less than 0. It is never negative. So we have the empty set or the null set, and we have no solution to this inequality. Now, what if we have greater than or equal to 0? 2x minus 5 is greater than or equal to 0. And this is always positive or equal to 0. So the solution set is all real numbers. Okay. Let's look at rational inequalities. We will be doing the same thing with the sign chart. It just is going to take a little bit more time, okay? Because we'll have more factors and more to include on our sign chart. So as you can see here, to solve this, the solutions are x equal to 1, -3, and 4. And we are undefined. At x equal to 4. Okay, so we do need those on our sign chart. And so we're going to have -3, 1, and 4. And again, we have to remember that 4 is not included in any solution set since it is, the function is not defined there, okay? So let's go ahead and find some test values. We can use -4, of course 0, how about 2, and how about 5? But again, you can use any number in that interval. And our factors or divisors are as follows. So plugging a -4, we have a negative, and a negative, and a 0, a negative, a positive, and a positive, a negative. And plugging in a 2, we have a positive, and a negative. And now a 5, they are all positive, okay? So multiplying 3 negatives together, we would have a negative. Here we would have a positive. Here we have a negative. and here we have a positive. Now, we are looking where it's less than or equal to 0. So we are looking for these intervals. So what we can see is negative infinity going all the way to -3. And we do want to include -3 unioned with, now we're going to start with 1, and we're going to go all the way to 4, but we cannot include 4 because the function was not defined at x equal to 4. Okay, let's take, and you could see that in this graph. Where is the function below or equal? So you could actually see here negative infinity going all the way to -3, and then we are from 1, whoops, that should be a bracket, to 4. And you might even see right here, there's a vertical asymptote at x equal to 4 because of this, okay? So graphically, at least we can see that solution. Okay, let's look at number 7. We will solve this rational inequality. And here, as you can see, we still need to set the function equal to 0. So we'll go ahead and do that. We have x minus 5 all over x minus 7 minus 3 is less than 0. And now we'll get a common denominator, x minus 5 minus 3 times x minus 7 all over x minus 7. And now we'll just combine like terms. You can see that we have a negative 2x plus 16 all over x minus 7 is less than 0. And sometimes it's nice to go ahead and have some factors. And as you can see, why don't we factor this numerator just so that we can see the solutions? So if we factor out a negative 2, we have an x minus 8 divided by an x minus 7 is less than 0. And these solutions are x equal to 8, and we are undefined at, so we have x equal to 8 and 7. And we have to keep in mind that at x equal to 7, we cannot include that because it makes the denominator equal to 0. Okay, so let's go ahead and make our sign chart. So we will place 8 and 7 on our sign chart. And let's go ahead and do our test values. And we could test 6, 7.5, and 9. And plugging those in, and as you can see here, we would have a positive, negative, and a positive. And so now if we have this, and actually we could put this negative 2 in front of this, and so this would change to a positive. I think it's a little easier if we do that. And you don't have to, you can do it at the end. But plugging that negative 2 in there, this would now become a positive, and this would still be a positive. And now I guess this would be a negative because we would have that 6 minus 7. There we go. So this would be a negative. And then, of course, we have a positive. And then let's plug 9 in there. Positive, but times a negative 2 is a negative. And a positive, and we have another negative. Okay, what were we looking for in the beginning? Less than. So we need these intervals where this is negative. And remember, we do not want to include 7. So 7 cannot be in our solution set since the function's undefined. It's 7. And we can write our solutions. We'll have negative infinity going all the way to 7. And then we'll start at 8. Excuse me, since it's less than, we don't want 8. And then we have 8 to infinity. Okay. Okay, let's look at number 8. And in number 8, we have to set one side equal to 0. Let's give that a try. So we're going to have 1 divided by x plus 6 minus 3 over x minus 2 is greater than or equal to 0. And we'll get a common denominator. So we'll go ahead and have 3 and then we want that greater than or equal to 0. So multiplying that through, we have x minus 2 minus 3x minus 18 all divided by x plus 6 multiplied by x minus 2. Okay, and that's greater than or equal to 0. So now we can factor, or we can combine like terms first. Let's do that. So we have a negative 2x minus 20 divided by an x plus 6, x minus 2. And let's go ahead and factor that numerator. And we have a negative 2, and we have an x plus 10. All divided by x plus 6, x minus 2. So those zeros are x equal to negative 10, negative 6, and a 2. And we need to remember that both of these cannot be included in our solution because they make that denominator 0. So now let's go ahead and create our sign chart or our number line. So we're going to place negative 10, negative 6, and 2. And let me move a couple of these over actually because I'll be able to fit my test value in there. And then we'll have some test values. And we can just use negative 9, negative 7, 0, and 3. Again, you can choose any one you'd like. And then let's put this entire factor, a negative 2 multiplied by x plus 10, an x plus 6, and an x minus 2. And we are going to be looking for greater than or equal to. Okay, so now let's plug those values in. So we have a negative 9 would be a negative, and a negative. And a negative 7 would be a negative, and a negative. I was just looking at this, and I think this needs to be a negative 11. And so, yes, I'll check the others. So putting that negative 11 makes this a positive, and that a negative and a negative. So this would continue to be negative. Okay, so now plugging in a -7, we would have negative, negative, and negative. So we will also be negative. And this would be a positive, because a negative times a negative is a positive, and then multiplied by a positive. Okay, we are getting there. And then plugging in a 0, we have a negative, a positive, and a negative. And of course, we're going to be positive. And then plugging in a 3, a negative, a positive, and a positive. So we're going to have a negative. Okay, so remember, we're looking for greater than or equal to. So we want these two intervals. So we will have negative infinity going all the way to -10. And we do want to include that because it's greater than or equal to. And then union. And then again, we cannot include -6 or 2 in our solutions. So we will have -6 going all the way to -2. -6 to 2, yes. And, yeah, I think that's it. And now let's look at two application problems involving polynomial and rational inequalities. So we'll begin with Fumio is constructing a circular koi pond in his backyard. What range of values may he have for the diameter of the pond if the area is to be no more, so area is to be no more than 78.5 square feet? What is the largest possible diameter? And we will use 3.14 for pi. So the very first thing we need to do is we want to find the area of a circle, and that's pi r squared, and we were given the diameter. So if we have, or we want to use the diameter because we're looking for the diameter, excuse me. So that would be pi times the diameter divided by 2 squared. And that would actually be 1/4 pi times the diameter squared. And using pi equal to 3.14, 1/4 times 3.14 times the diameter squared. If you would put that in your calculator, you'd get 0.785 d squared. Now, here we want the area to be no more than 78.5 square feet. So what could we say? We could say that the area must be less than or equal to 78.5. So 0.785 d squared is less than or equal to 78.5. Okay, we could factor out a 0.785, and we would have d squared minus, and if you would bring, I can do that in the next line. Let's do that in the next line, and I could actually move this over a little bit to give us a little room for our algebra. So if I want to subtract 78.5 from both sides, and then factor out that 0.785, and we get d squared minus 100, okay? And so now this is equal to d minus 10, d plus 10. So now we have d is equal to 10 or negative 10. Okay, so we cannot have a negative value for diameter. Okay, so we will not be able to include any negative values. Okay, and honestly, we don't even want to include equal to 0. Okay, so now what will we do? We can say that D is equal to 10 is the largest. But let's save that for a minute, because if we are solving this inequality, let's go ahead and put 10 on the graph. And we can put a negative 10 here and make sure that between negative 10 and 0, we cannot include any of this, because we cannot have any negative numbers. So now let's just double check that we're correct. So if we want to use our test values, and our test values are going to be D minus 10 and a D plus 10, and plugging those in, if we choose a number, such as, let's say 2, and then maybe 12, how about that? And then this would be a negative and a positive, and this would be a positive and a positive. Let me move that over. And then what would we have? This would be a negative, and this would be a positive. And so we want to solve less than or equal to 0. So that would give us this interval from 0 to 10. I'll go ahead and just erase this, and I can always rewrite that. So the interval we want is 0 to 10, and 10 is the largest diameter in the interval. So we would have D equal to 10 feet. Okay? Okay, let's look at number 10. The cost in dollars to produce X items is given by this C of X function. If the cost is to be kept below $20, so we want the cost below $20, how many items may be produced? So let's go ahead and set C of X is less than 0, and so we're going to have 0.5x plus 150 over x is less than, it shouldn't be 0, should be 20. Okay, so now we'll go ahead and get a common denominator after we move the 20. So we have 0.5x plus 150 over x minus 20 is less than 0. And now we could, why don't we rewrite 0.5x as 1/2 x, and now we could multiply every term by a 2x. Okay? And x is going to be positive, so we will not need to reverse our inequality. So we can have x squared plus 300 minus 40x is less than 0. And let me just rearrange those. And then that's pretty straightforward. X minus 30 multiplied by x minus 10 is less than 0. And we have x is equal to 30 and 10. So now if we create our sign chart and we have 10 and 30, and again we're looking for less than, let me find the less than 0 right here. Okay? And then we'll write our test values, and we have x minus 30, x minus 10, and we can use 0, 15, and let's use 50. So here we have a negative and a negative, and then plugging 15 in, a negative and a positive, and then plugging 50 in, of course. We have a positive and a positive. Okay? And now, remember, we're looking for less than. So this is what we want. So this would be between 10 and 30 is our solution. So the answer would be between 11 and 29 items inclusive, because we can't include 10 and 30. Okay, and that concludes this section.